Hello everybody, this is video 9.1. We're going to be looking at numerical expressions. This is going to be a relatively short one. There's only 5 slides total, and that's including this title slide and the checkpoint slide at the end. A lot of this is stuff that we've talked about before. A lot of this will be put more into use in later sections when we get into applications with variables and equations. But this is still an important section for establishing some ideas around numerical expressions. So let's get started. So we should define a numerical expression. So we see it's a mathematical sentence involving only numbers at one or more operation symbols. So you'll see missing from this description is anything involving an equal sign. So we don't consider an equal sign an operator necessarily, because it doesn't do any combining of numbers. So if we have an equal sign, then it becomes an equation. So if we have something like, here we'll do 3 plus 5, that's a numerical expression. It has one or more operators. In this case, the addition symbol is my operator. And we've got the 3 and the 5, so we've got the numbers. So this is an expression. Now, if I say 2 times 2 times 2, this is also a mathematical expression. I've got one or more, in this case 2 operators. I have my 2 multiplication signs. I'll make them a little bit bigger here. So I got 2 multiplication symbols. I got 3 numbers. And so this also works as a numerical expression. Now, once I say, well, hey, these are both equal to each other, then this becomes an equation. So once I insert this equal sign, so then this becomes an equation. But the individual pieces themselves are expressions. We mentioned this briefly when we're talking about ratios and proportions. This is very similar to that idea where we had ratios, but then once those ratios were equal to each other, they became a proportion. It's the same idea with how expressions can exist on their own, but once they're equal to each other, then they become equations. We can evaluate expressions using our order of operations. We've talked about this quite a bit before, our PEMDAS. So this is a little bit of review. So this is the PEMDAS is the commonly accepted mnemonic for this sort of thing. So just as a reminder, the P is for parentheses, but we should remember this includes all manner of grouping symbols. So it could be parentheses, could be square brackets, anything that groups together. So we work those from the inside out. So if we have nested parentheses like this, we start with the inside most parentheses, and then we would do those first, and then work to the outside parentheses next. We've got our exponents, which includes roots. So square roots, cube roots, fourth roots, those are all included under exponents. The square root's the same as being raised to a half power, so it makes sense that it would be included in exponents. M and D are multiplication and division from left to right, and then A and S are addition and subtraction, also from left to right. So we're going to do all of our grouping symbols, then evaluate all of our exponents, then multiplication and division from left to right, and then addition and subtraction, also from left to right. So this is how we're going to evaluate our order of operations. Probably doesn't need to be said because we've covered this already so much this semester, but obviously not following order of operations is going to yield the incorrect answer. And also, just as a reminder, that calculators don't always follow order of operations, depending on the type of calculator and depending on how you enter in the information. a lot of single line calculators, if you're trying to do 3 plus 4 times 5, this should be 23, because we should do the 4 times 5 to get 20 and then add on the 3. So this should equal 23. But for a lot of calculators, especially, like I said, single line calculators, once you type in the 3 plus 4, it will evaluate that, not 12, 7. It'll evaluate that for 7. So it'll evaluate that and then do the times 5 and get 35. Which is the wrong answer. So it only evaluates left to right. It doesn't take into account order of operations. Calculators like that, where it evaluates sort of as you go, you're not typing in the full expression, so it doesn't know that there's multiplication coming later that it should do first. So just keep that in mind in working with students. If there's no parentheses on the calculator to sort of force order of operations the way that it needs to go, you may need to write the problems in a way. You could use commutativity of addition and write this as 4 times 5 plus 3. So that way when it's entered in from left to right, they'll get this in order of operations. They'll do the multiplication first because that gets entered first, and then do the addition second because that's entered second. So just keep that in mind in preparing problems for students. So a quick note about fractions and order of operations. And this has not come up often. I dare even say that it doesn't really come up much at all. But just something to consider. If I wanted to do, say, 2/3 plus 1/4 plus 1/5. So in order to do this, I'm going to need to find a common denominator. And I could do this by taking the first two fractions first. And so I'll do these as 12s. And so I'm going to multiply this by 4, gives me 8. Multiply this by 3, gives me 3 plus 1/5. And so this gives me 11/12 plus 1/5. And then I can make both these have a denominator of 60. So multiply this by 5, and then multiply this by 12. And so I get 67 over 60. Okay, so the reason why I'm working through this problem is because I want to point something out that some students might notice that to go from here to here, we multiplied by 4 over 4. We multiplied this by 3 over 3. So we did multiplication, and then we did addition. We added these things together. Then we did multiplication again. We multiplied this by 5 over 5. We multiplied this one by 12 over 12. So you may get some students who ask, why are we working outside order of operations? And the answer is pretty simple. This multiplication of 4 over 4, 3 over 3, 12 over 12 is not really using an operation, right? So it's not something that's in the expression. So if you notice in the expression, we only have two operators. We have addition and addition. So using multiplication in order to find an equivalent fraction is not an operation specified within the expression. So we can do that at any time, and it doesn't alter our order of operations. So we don't need to do all the multiplication first, get a denominator of 60, and then do all the addition next. That multiplication of equivalent fractions is a separate thing. It's not an expression designated within the expression, so we can do it whenever we want. Again, not something that comes up very often. Pretty rare students will notice it or point this out, but it has come up. It's worth mentioning just so you're prepared to answer that question. So here's your checkpoint. So you have this figure here, this L-shaped figure, and so what I would like you to do is try to figure out how to express this area, the area of this figure, using at least two different numerical expressions. So we're going to break this up into shapes. This 40 goes from here to here, and this 10 goes from here to here. This 68 is this full distance, and this 58 is this full distance. So I mean, all the distances are sort of as they seem. So I want you to think about how you would break this shape up, and then based on how you break it up into presumably rectangles, um, how you would use the area of those rectangles to find the area of this figure. And you're going to do that by writing it out as different expressions. There's a third way using rectangles that you could do it as well. You could probably try to get creative and do it. Maybe I can think of maybe one other way. I won't give it away. That you could also express this, but I'll leave these for you to think about. Just a way of talking about and thinking about expressions. It's also related to some problems on the homework. So if you have any questions about this problem or anything else from this section, by all means, as always, please let me know. All right, thanks.